Hi, today we'll be discussing k-means clustering and seeing a few examples in R and Python. Our agenda would be what the algorithm is, how to choose the k-factor, what are different evaluation matrix, the application, and then we will work on data sets in R and Python. So what is the k-means clustering algorithm? It's an unsupervised algorithm where you don't have the labels, the target variable, you only have the input vectors. So what it does is it clusters your input data into different groups based on the patterns in the data. And the number of groups, that is K, is based on the elbow matrix, which we will be discussing in few minutes. And the main concept is the distance of the points, the data points from the centroid of your cluster. So a centroid is imaginary or real location representing the center of the cluster. The means in the K means refers to averaging of the data that is finding the centroid. Now, a few notes that the input data that we have, it has to be numeric, and above that it also the data has to be standardized. This means that the mean has to be 0 for each column and the standard deviation has to be 1 for each column. Now this is because it is always the case that you will have different units of data in different columns. So for example, if you have a bank data set, it would have an age column and it would have an income column. Now those are two different units. So if you standardize the data, you can bring them all to the same unit. And one of the other another problem that comes up with k-means is the local optima. If you use the same initialization of the centroid, you will not get different values of the centroids and you will never know if you have reached a global optima or a local optima. So when you run the algorithm, use different initializations of the centroids and pick the results of the run that yield the lower of the sum of squared distance. So if you keep these 2 points in mind, you'll be good with the algorithm. Now, the steps involved in the k-means is you specify the number of clusters. That would be a random number in the beginning. Say you start with 5. And then you initialize the centroids by shuffling the data set and then randomly selecting the k points from the data set without replacement. Now, you will calculate the sum of the squared distance between the data points and all the centroids and assign each data point to the closest centroid. And then compute the centroids of the clusters by taking the average of all the data points that belong to that cluster. So if you do this third point, you will get a new centroid value. And this new value will now be your new centroid. And then again, you will go through the step of computing the sum of squared distance between the data points and this new centroid, and then assigning the data point that is closest to the cluster, and then again calculating the centroid. So you keep repeating this process until the clusters of the newly formed until the centroids of the newly formed clusters do not change. The points remain in the same cluster and maximum number of iterations has reached. How do you choose the right value of k? like in K nearest neighbor algorithm, you had the elbow curve. So you will be using a similar concept here. You will be plotting a graph of the number of clusters against the sum of squares of the distance. Now, the cluster where this decrease in inertia becomes constant can be chosen as a right cluster value for that data set. Say, for example, in this sample data, in the sample plot, we see that the numbers between 6 and 10 is where you should focus on your K. So it can be 6, 7, 8, 9, 10. Now, you should also make sure that you consider the computation cost. So if you increase the value of K, the computation cost increases. So if you have very limited resources, you should consider taking smaller number of clusters. So if you have limited resources, you might stick to 6 or 7. But if you have really good resources with you, you could probably go to 9, 10, 11 and then get a good cluster set. Now, for an unsupervised learning algorithm, the evaluation matrix is very different from what you have for supervised learning. In supervised learning, you have confusion matrix and you have the accuracy and misclassification. You don't have such things in unsupervised learning algorithm. You will have to come up with your own set of evaluation matrices that you think would be good. So there are two very common matrix that you have for k-means clustering. One is inertia, where you calculate the sum of the squared distance between the data points and the cluster centroids. This distance has to be as low as possible. If it's low, then it belongs to the right cluster. Now, another method is to get the done index or the salute analysis. In this, what we do is we calculate the average distance of all data points from the same cluster and the average distance of all data points in the closest cluster and compute the coefficients. So this would be the inertia, and this would be the inertia, and this would be the distance between the clusters. Now, if the value is more than 0, then the sample is very close to the neighboring clusters and you don't have a really good classification. But if the value is 1, the sample is far away from the neighboring clusters and you have a very idle cluster sets. Now, if the value is -1, the sample is assigned to wrong clusters. So, done matrix is another way of calculating your how good your clustering is. K-means is used in several segmentation analysis. So you can classify your customers into different segments. You can do market segmentation. It is also used in recommendation engines and computer visions. So let's implement the k-means clustering using Python. We will be working on a wholesale customer segmentation problem. The data is available on the UCI Machine Learning repository. The aim of this problem is to segment the clients of a wholesale distributor based on their annual spending on diverse product categories like milk, grocery, region, etc. So we will first import the required libraries. Next, we will read the data and look at the first 5 rows. We have the spending details of the customer on different products like milk, grocery, frozen, detergents, etc. Let's get some statistics on the data. Here we see that there's a lot of variation in the magnitude of the data. Variables like channel and region have low magnitude, whereas variables like fresh, milk, grocery, etc. have a higher magnitude. Since k-means is a distance-based algorithm, this difference of magnitude can create a problem. So let's first bring all the variables to the same magnitude. By this I mean we have to standardize the data so that everything comes in the same unit. We'll be using the standard scalar library. The scales now look similar. Next, let's create a k-means function and fit it on the data. Here, I have used the k-means initialization, which generally produces better results compared to random initialization. Now, when we check the inertia, it's almost 2600. Let's see how we can use the elbow curve to determine the optimum number of clusters in Python. We will first fit multiple k-means model, and in each successive model, we will increase the number of clusters. We will store the inertia of each model and then plot it to visualize the result. We have stored the data in the SSE list. Looking at the elbow curve, we can choose any number of clusters between 7 and 12, because at that point the inertia is not changing much. Let's set the number of clusters as 10 and fit the model. Finally, let's look at the value count of points in each of the clusters formed. There are 155 data points in cluster 0, 83 in cluster 5, 76 in cluster 4, and so on. This is how we can implement k-means clustering in Python. Next, we will be implementing the wholesale customers data in R using the same k-means clustering algorithm. First, we'll be loading the libraries, cluster for clustering the algorithm, and core plot for the correlation plot. Next, we'll be loading the data set and take a look at the first 5 records. In our exploratory data analysis, we'll be checking the structure of the data using str and summary statistics using summary, and then the correlation plot. Let me show you what the correlation plot looks like. If we look at the statistics, we see that the data is not standardized. We have to first standardize the data, or we could simply ignore those columns that do not have data standardized if they don't affect our analysis. In our case, channel and region are the only 2 columns for which the data is not standardized. All the other columns are on the same unit. So in this k-means clustering analysis, we will be ignoring those 2 columns. So this is what we have done here. Next, we'll be creating a salute function where we will be implementing the salute and finding out the evaluation matrix for the k-means clustering. We have set our k values ranging from 2 to 10. When we apply the salute score on this algorithm, we can plot a graph between the number of clusters and the average salute score. So this is how our score looks like. Our elbow curve looks like. So in this elbow curve, we see that at about 7, our cluster, the salute score doesn't decrease as much. So if we take our k-means as 7 and run the cluster algorithm, we will be able to get a good set of clusters. Uh, we can then plot the cluster plot and see what it looks like. So these are our 7 clusters. They're not properly segregated. So our 1, 5, and 7, we can still see them, but clusters 2, 3, 4, and 6 are all mixed up. So this is how we implement k-means clustering in R. Thank you.